Okay, folks, so this is going to be a little bit of a run through on how to complete our Ohm's law activity for today. Making sure, there we go. Yep, so this is gonna be just kind of a run through on how to complete our Ohm's law activity. You're gonna have some time in class to work on these. Right now I'm out at competition for robotics. So I will be back relatively soon. Should be back on Monday. But what I want to talk about here is this Ohm's law thing. We've talked about it in class a number of times. We've talked about amps, we've talked about voltage, we've talked about resistance. We haven't dived into the math and the relationship that exists there. Okay, so if you look through this, the thing that they kind of talk about here is the direct proportionality between current and voltage. So if we dive into what that means, it really means this. As our current is increasing here and as our voltage is increasing here, we have a one-to-one correlation, right? So if I try to flow 5 amps of current through a 1K resistor, I'm going to get 5 amps, or I'm going to get 5 volts, right? So a one-to-one proportionality here, okay? Now, for some people that means a lot. For me, that doesn't really mean all that much. And this is kind of the working definition or the information you really need to know here, okay? This is how we break down Ohm's law, okay? I've always heard it called V over IR, but there's a lot of other ways of using it. As you can see here, it's very common in all of our reference tables for Project Lead the Way for them to give us all these 3 different formatted versions of Ohm's law, right? And realistically, like, that's kind of nice to have. A lot of times you'll actually see this wheel given, which includes power formulas in there. In like every electrician's handbook, this is located. I just bought one the other day. It had this little wheel in it, right? So more often than not, you are given the formula. So I'm not going to stress over you trying to memorize that or anything along those lines. And here you can see the worksheet you're completing today. I've given you those formulas. So voltage, right? Voltage is the electromotive force behind the electricity. In all reality, a lot of times we just convert it and think about it as pressure, right? So voltage is the pressure pushing the electrons through the wire. Current is a measure of how many electrons are flowing past a given point, right? And oftentimes we make the analogy to water flowing through a hose or water flowing down a river. Again, we talk about current, it's how wide the hose is or how wide the river is. Resistance is a force that's keeping that electricity from flowing down the river. A lot of times we think about it as a kink in the hose or maybe rocks and boulders in the river that's stopping the water from being able to flow. Okay, so you're going to go through this. You'll see that the first problem in each different category and each different use of the formula is going to kind of give you some steps to walk through. So here you see we are solving for I is current. I don't know why that is the case, that they chose I a million years ago as the symbol for that, but I is current. So current is always going to be measured in amps. So you'll see here your answer is going to be in amps. And again, this is incredibly easy stuff, right? We're going to take 120 divided by 2. We should end up with 60 amps here. Okay, super easy stuff. But please show the progression. Show each and every individual step you have to take to get your answer. It shouldn't be that hard. Okay, scrolling down through here, you got a bunch of them to solve. On this one here, number 7, I'm asking for you to numerically put in your birthday, right? So put in the month you were born and put in the day you were born. I don't care about years, okay? And once you have that done, I want you to use your month number as voltage, and I want you to use your day number as resistance, okay? Plug those 2 in here, and you should get a current output, okay, of how much current would theoretically be flowing through that circuit. One more current problem there. And then I'm asking you to solve this problem here. I've got a giant chop saw with a huge motor on it. I'm concerned that it's going to pop the breaker in my garage. So I check the resistance of the motor. The motor comes out at 6.63 ohms of resistance. I'm running it on a regular old household outlet, okay? You need to know what voltage that is. We've talked a lot about it. You should know that by now. If not, go ahead and Google standard North American wall outlet. It'll spit out the answer to you, okay? So figure out what voltage a wall outlet is, put that here, and then use the formula we just did up here, right, to figure out how much current that motor is going to draw, and tell me, is it going to pop a 15 amp breaker? That's very likely what's run to your garage. Looking at voltage, okay, so we've got our voltage here, we've got our current, we've got our resistance. In this case, we got 5 ohms of resistance, we've got 6 amps of current. You got to plug all this stuff in, figure out how much voltage we have flowing through here. One thing that I want to reiterate is this is not math class, right? We are not working with really pretty numbers. For some of these problems, especially going forward, you are going to have very, very strange answers, very ugly numbers, decimals, all that other sort of stuff. So chug on through here, chew up all these things, answer them. They're not that bad. Yep, run through all these, solve for all this voltage here. This is a problem where I'm trying to recreate lightning in my garage theoretically. I'm dealing with 30,000 amps of current, and I'm dealing with 100 ohms or 10,000 ohms of resistance. I'm sorry. And I'm looking to find out how much voltage I would theoretically need out of my AA battery to recreate lightning in my garage. So tell me what voltage I'm going to need and tell me whether or not this is a good idea. Okay, now we're down to resistance. Okay, again, we're just plugging and using these formulas from up here. It ain't that hard. Okay, now we're solving for resistance. Okay, so there's my formula. I'm plugging it in. You can see we have 3 1.5 volt batteries. So you need to do 3 times 1.5, put your voltage in here, and then take that number and divide it by the number of amps we're planning on flowing, and we'll work out what our resistance is going to be. Okay, so as this is just an alarm clock problem working with weird numbers. We're using 4 batteries in this problem instead of 3, so you got to figure that out. This is a good one, actually. I really like this one. So let's pretend hypothetically I've bought a very old beat up welder. The welder claims to draw 30 amps. It plugs into a standard North American dryer outlet. Okay, so that's going to be a little bit of a spicier electricity, a little bit higher voltage than our previous just regular old outlet. A dryer outlet's going to run at a different current. You should know this. Okay, so I've got that spicy 220 volts coming out. Okay, so what I should be able to do is I should be able to look at how many amps it's going to draw and look about how much voltage I expect it to take in, and I should get a resistance number here. That resistance number would be something I could check before I plugged it into my house and burnt down my house or tripped a breaker or did anything bad. I should be able to check this beforehand and say, okay, I've got 30 amps and I've got, let's say, 6 ohms of resistance, and I have 100 or in this case 220 volts. This welder is good to go. It's not going to burn my house down. Obviously, still should probably like not plug it in because it's very beat up and old and gross, but figure out how many ohms I should see there. Okay, this is another voltage problem. How much voltage would be necessary to generate 20 amps of current in a circuit with 1.5 ohms of resistance? Again, we're just using our formulas up there. We're looking to find voltage here, so you should know what formula to use. On these last 3 problems, what I want you to be doing is I want you to be designing your own problem. Write a word problem in just like you saw up here, but I want you to go ahead and write it in for me to solve. Okay, I do want you to do the math down here to prove to me you know how to do it, right? But this is, to me, showing me that you actually have mastery of this, you know what you're doing, okay? So write a word problem in here about, you know, maybe a blender you bought on the side of the road or something along those lines, okay? Just like I've done for you up here. Write me a problem and then go ahead and solve it using your math to find voltage. I want one problem that solves for voltage, one problem that solves for current, one problem that solves for resistance. The lights just turned off on me. They do that around here. Y'all, that is it. Please be wonderful students for Mr. Soretto. Please get your work done. Please get this thing turned into me. You should have a physical copy of this to do, as well as an online copy that I'm about to upload to Schoology right now. Have a wonderful day and enjoy your weekend.